Today, I'm joined by Mark Weitzel of Microsoft, who works on a product called TypeSpec that we actually use at Zuplo. TypeSpec is like TypeScript for OpenAPI. So, as you'll know, Zuplo is a programmable, edge-native, serverless API gateway that is natively powered by OpenAPI. We're big fans of OpenAPI, but it does have some drawbacks. It's very verbose. It's kind of boring and hard to write. It's very repetitive. If you're an engineer, you might hate some of the repetitive nature of like creating a schema for inserts and creating a different schema for updates. TypeSpec solves a lot of those problems, and you can write, a small TypeSpec file that generates a lot of OpenAPI and does so in a way that engineers will love. So we're lucky today to be joined by one of the people who work on this every day at Microsoft. So let's go chat to Mark as he takes us on a journey from how you can use TypeSpec to generate a simple OpenAPI file to how you can even use it to drive, a core part of your governance across a lot of APIs like they have in Azure at Microsoft. Mark, welcome. Tell us a little bit about yourself.
Thanks. So glad to be here. Really excited to talk about TypeSpec. Mark Weitzel, I'm a principal product architect at Microsoft, and I think that means I get thrown into a lot of different things. One of the things I've worked on is the Azure Developer CLI. If you've been playing around with that, that helps you get up and running on Azure very quickly. I'm working on some platform engineering efforts now. And the other thing that I do is I work and I run our API stewardship board, which is a group of architects. We have folks from our field team, our CTO office. It's a group of sort of experts that think about the developer experience from an API perspective and work across our Azure service teams to help build better, consistent, higher quality APIs for our developers.
Awesome. And so you're at Microsoft. That's your role. A little bit of background on you. You used to be an engineer, or you still code these days? Are you more a sort of product person? Like, how should I think about your?
It's a little bit of both. Yes, I used to be an engineer by trade, and have moved and sort of in that. My favorite language, I say it all the time, is still small talk. I'm dating myself. I get it. But yes, used to be an engineer by trade, and over time, I've done various things. I've been in product management. I've sort of a technical product role. Prior to Microsoft, I was at New Relic, where I led engineering teams and built the developer platform and developer experience around that product. So I've done a lot of different things in my time, and it sort of keeps me on my toes, and it's been a lot of fun.
So small talk's your favorite language. I'm going to have to go with JavaScript, maybe TypeScript, which is fitting for today. Actually, if you're watching on YouTube, leave a comment. What's your favorite language of all time? And if you know what small talk is, mention that as well. Why it's famous. Awesome. Okay, cool. Well, look, we're here to talk about TypeSpec and have a little caddle. There's a little pun in there.
Yes.
So what is TypeSpec? What is this thing we're talking about today?
So TypeSpec is a new language that we've come up with to help really design APIs and create really good open API definitions. So you can think of TypeSpec as TypeScript is to JavaScript what TypeSpec is to OpenAPI, right? It's a language for us to build and create consistent, high-quality OpenAPI definitions that feed your entire tool chain, right? And it's a language, right? It's very JavaScript, TypeScript inspired, right? Some of the folks that worked on TypeScript built TypeSpec, so it's going to feel like you're building a language, and it's going to then produce OpenAPI documents, whether it's OpenAPI 2, OpenAPI 3, and it's a great experience for creating very complex OpenAPI documents in a very specific way. And this is a challenge for us at Microsoft. I mean, we have hundreds of service teams building services, and we have thousands of developers building services. And so you can imagine that as as our surface area grows, as we add more people to teams, as people change and switch teams, and there's turnover. Like there's a lot of knowledge transfer that's sort of lost in building OpenAPI, and it's not the friendliest thing to go build if you have to craft one of these things by hand.
Right. Okay. Now that's interesting. That I agree with. In fact, just this morning, just before we got on the call, I was working on some OpenAPI stuff with a colleague, and it kind of reminds me of XAML, if you remember that language in WPF world, where it was sort of very powerful, but writing it by hand was just a lot of work. It was just hard.
I was going to say, what's interesting is so what some of our teams do is they'll use something like Swashbuckle, where they'll write the code first and then produce this OpenAPI document. And as a review board, as an API steward where we work, we can tell right away when somebody has done that, right? There are so many problems with this, and each team that does that does it slightly differently. So it's not like you're getting consistently bad things. You're getting consistently things that are consistently bad, inconsistently bad in different places. And so we can tell right away when somebody is taking a code first approach versus a design first approach.
And so what I'm hearing there, if we can sort of put this in a frame for a second here, is that you're saying, it sounds like your opinion is strongly that you think design first yields better outcomes.
Yes, it does.
Yeah. Okay. That's interesting. So this TypeSpec thing, what's the best way to really grok this? Like a demo, maybe?
Yeah, let's jump in. There's a couple ways you can get started, and we'll walk through a little bit of our journey as well, because it is still new and we're still learning what we can do with this language ourselves. And I'll talk a little bit about what we're doing inside of Azure, a little bit about what the Graph team is doing as well. We really think this has the potential to be sort of the common approach of doing API design across Microsoft, and we're starting to see some really good benefits there. One way you get started is we have a little playground. So let me share my screen here. Let's see. And I'll share my entire screen. So here we go. So here's what we call the TypeSpec playground. And I still like calling it cattle, by the way. I know all the Microsoft people are probably going to get mad at me for saying that, but the cow puns they're just irresistible, right?
Oh, I hadn't even thought of cow puns, cattle. I'd thought of cuddling puns all the time. Like it sounds a bit like cuddle.
Yeah. Join the movement, Josh. Okay.
Well, by the way, in the show notes, the link to the playground will be available. So if you're looking underneath the video, you'll find the link to this playground as well.
So let's take a quick look at an HTTP service here. And again, one of the things that we think about is TypeSpec and OpenAPI. They really, really work well together. And I think of OpenAPI very much as the contract, right? This is the contract between the server and the consumers of your APIs. And as a contract, you want it to be as precise as possible. And that prescription, tends to make very long things, right? I mean, think of, if you've ever done anything, like if you bought a house, like it's a pretty, I just want to live in the house, but you get this long contract because it covers everything inside of there. So here is a basic TypeSpec document. And right away, you can see that this starts to look and feel like a code experience versus I'm writing YAML or JSON or something like that. And I can flip over here to the UI that should give me the nice UI that we're all sort of familiar with. And I can do things like add new models in here very quickly. And we were talking just a second ago about this sort of design first approach. And a lot of times what we see, and we're just going to keep things simple and do widgets and gadgets here because that'll keep us focused on what we're really talking about.
So actually, just if I can jump in just a second. So what's going on here is there's two panels in this playground. The left panel is like the input you're putting in TypeSpec. And then what's happening is when you make a change, it's automatically generating the output on the right, and you've got different presentations of that output. You can either see the raw YAML or you can see what the Swag UI would look like.
Right, correct. So there's the raw YAML, and here is the Swagger UI.
And I don't need to press save or anything. It does it dynamically as I type in the left.
Yes.
Cool. Okay.
Yes. So all my typing mistakes will come through very clearly here. Okay, so and you can see we just added a new model here, and so this is actually one of the very first why design first is important, right? Because you start thinking about what are the resources that I'm exposing, what are the things my developers are going to be working with, what's the concept I'm trying to express right away. And you're not sort of in code thinking, oh, I got this thing and I got a C# model, and you're like, well, how's a Python person going to think about that, right? And that's what actually one of the big things that we see is a lot of our developers are C# developers, .NET developers, and we produce SDKs in lots of different languages, and that translation there is very different if you're experiencing Azure through a Python experience. And so by bringing this part in, you're really thinking about what are the resources that I'm exposing, what do they look like, what are their characteristics that they have, and then you think about how do I expose those on the wire, right? And in TypeSpec, we use emitters to produce OpenAPI, but you can use emitters. You can write your own emitters to do things like gRPC if you wanted to. And so by moving to design first, you think about the concepts that you have, and then you think about how do I get those from point A to point B. Sometimes it's gRPC, sometimes it's REST. There you go.
Got it. There's a couple of little things I want to dive in on here that interest me. So I look at the schemas section on the right there. I can see we've got a widget create, and a widget update. But you've only got one model called widget. So how did we end up getting three widget schemas, and what's going on there?
Yeah, I'll talk about that in. Let's save that little point for when we get a little bit deeper into the demo. But the short story is, this is where we try to say what's required on create versus what's required on update, right? Because you could have required fields on create that aren't necessarily there on update. And so you could think of these as more request bodies than actual models themselves. This is the resource, and this is what we need to pass on the wire. So we're trying to get a little bit of help there.
And that's why I got excited and asked that question, because I know it's painful writing the same schema roughly four times, that has subtle difference because there's no ID on insert or something, right?
Exactly.
Okay, interesting. So we're going to get into that. So that's exciting. Okay, yeah. Well, I won't interrupt again. Anything else you want to show on the playground, or?
Well, I was going to do a little cut and paste here and all that other stuff in refactoring, but let's just hop into VS Code, because the thing that's really exciting about TypeSpec is you get first class experience with IntelliSense, type ahead, all of those things. So it feels like you're building a piece of code here. But you can see what I've done here in this little demo is now I've just said, hey, I've got a route for gadgets, and I've added my little gadgets here, and I've done my compile. I should show people how to do the compile. Okay, so you can do TSP compile. We call them teaspoon files, and you can do a compile there, and then there you go. It's going to compile, and what it's going to essentially do is run through my emitters, and you can configure the emitters in your TSP config. So here I'm saying OpenAPI and emit the file type of JSON over here, and that's what gets produced.
Oh, nice. So you can choose whether you want YAML or JSON output, etc. This is very similar to TypeScript. You have a TS config, you have a .ts file, you've just put a P on the end of it for the spec.
Now I know we're recording this, but I still like cattle, because then you could have .bs files, but maybe we should edit that part out. I don't know. All right, and then I can do a watch on this too. So as I go through this, it'll automatically update. So I'm sort of watching this directory for changes here.
Got it. So TSP is like TSC, I think it's called in TypeScript, right? That's the TypeScript compiler. Just quickly though, where do I get that? Is it already built into VS Code, or do I have to do something to get the support here?
It's very simple to do. Let's do that. You just do, once you get TypeSpec, you just do TSP code install, and it will drop it into VS Code for you.
And I get TypeSpec as an npm install or something?
Yeah. There's instructions on the website, which
we'll include all this in the show notes at the bottom. So
yeah,
cool. Okay, but it's pretty easy. It's just a couple of installs and you're good. Okay.
Yeah, it's very simple. Okay. It's so simple, even a cow can do it.
We're just gonna have a lot of cow jokes from now on.
They never get old. They never get old. Like, I'm a dad. They're dad jokes. Sorry. All right. So the other thing that I've done is in the show notes, you can put a link to the repository, but I've sort of crafted this demo as a set of branches in the repository so people can follow along if you want. So here, what I've done is the same TypeSpec file we were looking at, and I've just created a new route for gadgets here. And so I just did copy paste, and then replaced widget with gadget. And you can see now that I have a complete, nice, well-formed OpenAPI. To your point, here are the, gadget updates, gadget creates, and you can start to see the sort of the management of this. And imagine you're doing this with multiple developers. We're already just with something very simple. Our API document's growing, right? Because we want that prescriptive thing saying this is what comes across on a create, this is what comes across on an update. Now we're expanding our models, etc. Right? Now, where TypeSpec really starts to shine is when you think about all the things that you're going to do as a developer, as a service, providing a service. You're going to be refactoring things. You're going to be changing things. You're going to be adding things, and you want your API to be updated and working accordingly. Now, interestingly, one of the folks I mentioned, our API stewardship board. One of our folks is in our field organization, so a member of CSE, and goes out and works with customers all the time. And they were struggling with this. How do I enable multiple teams working on a project, right? How do I enable my front end team, my back end team, et cetera? And so what they found is they were doing a code first approach, and they would generate out their API. And that actually was a blocker, because now they had to have a developer go in and sort of stub out what they thought the API might actually look like, so they could produce the OpenAPI document that their front end team was going to go off and start working on and building and starting to write their front end code around. And so that ended up being a blocker, because that loop, they're like, oh, that's not really the code we want, right? And so they would change it, and now it's like, and so you get into this sort of vicious cycle. And so he went in and showed them, well, if you think about TypeSpec ahead of time, your resource design ahead of time, and produce that, now you can actually enable both of those teams with an agreed upon contract, and you have a way to reason about your models differently from how you expose them on the routes and things like that. So it ended up being they were really, really excited about it, and they're starting to experiment more with TypeSpec, and they're excited about building libraries too. We'll talk about that as well. So let's see if I can do a git checkout. Step one. So here's step one, and the way we're going to break this down is sort of representing our journey, right? Talking about models first, how you might, interesting things you can do with models and refactoring models and adding models, and then talking about routes, how you expose those models over REST, and then how you can make something reusable in a library. So if you think about kind of this discussion in three parts, those are the three parts. And we're at the model part now. So let's look here at our model part. And I just checked this branch out, and you can see I've got an update here. And I'll just touch my OpenAPI, so we'll go off and update. So what have we done here? There's a couple of things that are interesting here. So one is, I think I added the OpenAPI to ignore in Git, but I checked it in, so it's still going to be there when you go. But this is an interesting discussion that we've seen various teams have. one of the things that we're trying to say is treat your OpenAPI as a generated artifact. You can put it in part of your code pipeline. You can build all this stuff as part of your pipeline, because then that resists the urge to go hand craft it and hand tweak it. And so it sort of is a way to emphasize that, API first approach. If I can't touch the contract, I gotta touch the thing that produces it, right? And so that's just an area of sort of back and forth we're having. Is that the right practice? Is it not the right practice? I've said TypeSpec is still new, and so we're still learning here. So a couple of things that we've done here. So I've started expanding out here, and notice one of the things I did is I created this created on time, and I added that there. So all of my widgets and gadgets, and now I added a wingding. They all sort of, they kind of look the same, right? And so I've added things, and like I'm just adding and adding and adding, right? And now I've got 3 models. I've got, the error is the same. I said, I really want these to be widget interface so people know that they're interfaces. And of course, I did a little cut and paste here, and I did a cut and paste, and I did, gadget to wingding and all that other stuff, right? So I'm just starting to build out this interface, and I can see here, yeah, I've got wingdings. They look the same. Everything starts to look and feel the same. Cut and paste works here. Okay, so good so far. I mean, feels like a normal development cycle so far. All right, so let's go and look at part 2. Now, there were a couple of things I started to realize, which is, wow, all those models really do look the same. So can I create like a base model for that, right? And so now this starts to feel a lot more like code. Oh, I've recognized some common things, and I'm going to factor those common things into, kind of a base class or a base thing that I can go off and use. And so that's what I did here in the base thingy-majig, right? Is I created this base model, and I said, these others extend this base model. And so now you can see the differences are what's highlighted here, not just sort of repetitive notion. And I'll just touch my API to make sure it updates. You're going to see all of these APIs have stayed the same, right? My models are going to be reflected differently, but basically the API contract hasn't changed. And there's a couple other interesting things in here as well that I want to point out. So let's look at my base thingy-majig, right? So I have visibility, read, and update. So I can say what the ID is going, how the ID is going to manifest itself. And it's going to say the ID is on the path. And that's what gives us this ID right here, okay? So I'm saying this has to be on the path, and away we go. Color is optional, right? Not everything has a color. Now, manufacturer, is that really required? Do I need to have a manufacturer? Does everything need to have a manufacturer, or can I just have one of these things? Now, without TypeSpec, if I needed to make that change and say no, that's going to be required, and let's pull up one of our gadgets here and see if the magic actually works. Here's my required field of manufacturer. And if I go down and I look at widgets, here's my required field of manufacturer. And you come along and say, well, we don't always have a manufacturer, right? And so instead of having to go into each one of those models, I can just say that, no, this is now not a required field. And you see that goes away on all of these, right? So that real powerful, I'm working in a code experience and generating out the artifact saves me all that time. And you can see this again, now our model is our OpenAPI document is starting to grow, right? This is what these things do. Okay, so that was kind of fun. Yeah, so here's another thing that I really like. We noticed that everything had another common thing that we had were the updated on and created on, and these things are again attributes, fields of everything, every one of our thingy-majigs. And so I can actually spread those things in to the end of the model. Okay. So if I go look at the model here, let's see.
So that's sort of copied from the spread operator in JavaScript, right?
Exactly.
Where you can do the ... and it adds the properties to the,
exactly.
to the object.
And we use that all the time. And we'll little foreshadowing. We'll show that how you can add it to like the path to enforce some things that you want to add to the path, etc. So we use this quite frequently, and it's really nice. It's a really nice way. And again, you can see that these are required, but they're only required on read. So going back to your point before, if we look at like the widget update, they're not there, right? So this is the request body, if you will, for an update, and we don't include them because of that. These things are read.
Right.
And then,
this is a huge pain for anyone who works on OpenAPI. It's having to create like several different models, even if you're using tools like Stoplight or whatever. You end up. What's nice about this, if you're an engineer, what you've shown so far, I think, is engineers don't like repetitive tasks that feel manual. They want to automate everything, and so the amount of reuse I'm getting here of these little components, like the model, I can just annotate it correctly and I can reuse it in lots of different, or it sort of happens automatically almost, is very slick. Yeah. Very, very slick. It's a much nicer way for an engineer to work with this type of data, I think.
And I'll talk about talking about sort of death by 1,000 cuts, right? What are some of the death by 1,000 cuts? How about little inconsistencies between teams, right? And here I used enum as an example, right? So I can take the colors and I can say that these things are colors, and now I say the gadget is color yellow or color green, and it's not color yellow with a lowercase y or color yellow with an uppercase y. It's just yellow, right? And now you can see one of the things I've done here as well is I can add just a space there to make that a little clearer. There's this notion of a lot of times one of the areas we struggle with, and this is a bit of an arbitrary example, but we struggle with polymorphism, right? Think the kind of VM that you have. There's 6 different kinds of VMs that you might have, and you have to serialize them down into the right class in like your SDKs. And so there are times where if I just say, hey, this is a color, I'm just going to get the enumeration. But I can be more specific and define sort of a widget colors and say red or blue, and this will give me the one of in the schema in the OpenAPI document versus in any of that I have. And that's helpful, again, for polymorphism when you have to take that thing off the wire and be really prescriptive about what it is. So this is a bit of an arbitrary example, but this is an example of the power of the language of how you can go off and actually do some of these things. Now, on to one of your favorite things, errors, right? Here's another thing that just kills us. We see teams model errors differently, right? And let's forget about like if there's a standard error definition in the industry, all that. How about we just pick one and use that? And it turns out that a lot of times teams just model errors differently. Now, we've done the Azure REST API guidelines. Those are on the web. You can go find them. And we say, this is the error structure you should use inside those REST API guidelines. Yet teams still come to us with different error models. And that's another indication as an API steward. We look at that and say, usually the question I ask is, have you referenced our guidelines? Because this is a telltale sign that they're going to do other things wrong or not in compliance with our guidelines, right? They're going to use post for creates where we recommend a patch.
This is like the no brown M&Ms in the bowl at the, do you know the story?
Van Halen, yeah. This
the
is
Van Halen story. Yeah, okay, yeah. This is the indicator that they've probably screwed up the lighting as well, right? If they haven't read that bit. Got it.
Yeah, this is exactly what it is. And it's funny you bring that up because one of my colleagues who works with me on TypeSpec, Mike Kistler, has used that exact analogy of this is no brown M&Ms, right?
Actually, we should explain that. So if you don't know, the story goes that Van Halen would write this long document of what they expected from the setup at their gigs. So if they're performing a concert, and one of the, did they call it a rider? I think it's called this document. I think that's the name.
I think so.
And one of the clauses buried in it is that there should be a bowl of M&Ms or Skittles or something, and there should be no brown M&Ms or no M&Ms of some color. It should be removed. And obviously, most people would just think this is some, petulant, crazy pop star doing what pop stars do. But the story goes that it's actually a sort of a sniff test. If the people following the instructions hadn't noticed that, then they would have much less confidence that they've got the whole rest of the setup and the lighting and the audio rig correct. So that's the story we're referring to. But sorry, go ahead, Mark.
Yeah, so it's a great story, and it really is it's a leading indicator. Okay, so I think down here we left. We're still focusing on models, so all of those are the same. But those are the big things that we've talked about now. So we've refactored errors, and notice when I refactored the error, so I have a much more sophisticated error model here, right? I didn't have to change any of my operations. They just naturally took that new error model. And so if we go look at our operations up here, we go look at one of our operations. Let's take this one, right? We can see that our error should drop in here nicely, okay? Unexpected errors. So there we go, right? So now we have a much more clean error model, right, for what we want. Let me go ahead and save that. Let's see. And there's our schema. And so I can expand that out, and there we go, right? So I didn't have to change any of my operations because I changed the way that my error is. And again, it's that sort of code-like experience there. And that sounds like a little detail, but it's huge, right? Okay, so let's see. Now let's go to step 3. So if you're following along, you can, let's do git stash. And then check out step 3. There we go.
So for the listeners, actually, Mark has a repo with all of these branches in a GitHub repo, so everyone can follow along with the demos, and we'll include that in the show notes below.
Yeah. Okay. So now, let's see. So now we've talked about models. I think now is when we're going to start talking about operations here. All right. So now one of the things that we talked about before, and let me see if I can make this a touch bigger over here so we can see that, and then maybe make this a little bit smaller over here and make my screen just a touch bigger. Okay. So now if you recall in step 2, we didn't mess around with our interfaces, right? With our operations. We were just really focusing on the models. And so now we've got our models into a place where we're pretty happy with them. So now let's start thinking about how we can refactor our interfaces to have, kind of this common interface. So the first thing that we did is we created this common resource interface, and that's great. Like, get lists, we say, hey, these are lists, these are reads, these are creates, these are updates, these are deletes. And you can see we've got a special operation here because we have this notion when you're doing an RPC-like thing, we have a special way to say that's a post operation. We want the path to look a particular way, and away we go, right? And so we created this special way to extend an interface, right? So I have an interface, and now I create this special post operation, and away we go. And you can see here's the route, it's the analyze, it's a post operation, and here's the information that it takes in. It takes a path ID and a string, and away we go, right?
Got it. So actually, just to clarify my understanding, then, if I look above, I see this interface called resource interface of type T. It's a generic.
Yep.
And you have list, read, create, update, delete. Those are well-known words to TypeSpec. It kind of understands what they mean, right?
Actually, the decorators are. So
I see.
Yeah. So these TypeSpec has this notion of decorators, and that's what the @doc is here. That's what the @get is. So this tells me this is a get operation here. and I've just named it list. Okay, so it's not the list, the read, the creates, it's the decorators. And one of the awesome things about TypeSpec is you can write your own decorators, right? So imagine you've got policy you want to put on an endpoint. You could write a policy. Imagine you've got different special visibility rules that you want to put on. And there's a number of things that we do in our common library that are Azure specific, that we sort of make Azure specific decorators for. And so you can write your own decorators here. And it's actually these that are what TypeSpec knows. And backing up just a little bit, TypeSpec itself is really a very, I don't want to say a simple language, but it's a very straightforward language. And like many languages, the power really becomes the libraries that you build on top of it. So these are coming from the HTTP library. So if you're doing a gRPC library and you're only doing gRPC, maybe you have different ways to decorate your what would be the equivalent of your routes, if you will, or your interfaces. Right?
Got it. Okay. Yeah. Makes sense. And so because you have that at route /widgets, that's how that combined above there is how we know that the read, for example, where it says at get read path ID in that common interface above, that's how you end up generating a path in OpenAPI that's going to be /widgets /ID in the one you're looking at right there.
Right. And because it's a common interface, it's going to work for gadgets as well, right? So all of these extend the interface there. And here, now what I've done is, I've realized that, hey, wingdings don't have that special analyze operation, so I've just said it extends the resource. So now think about, as somebody building an API and as an API steward and somebody helping a team build a consistent API that's not just consistent for within your own service, but as organizations have very large API surface areas, right? Now you say, hey, if you just do the widget interface, I know everything downstream is going to be correct. It's going to be accurate. It's going to be generated the way I want. All the things that comply to our guidelines. That just by saying you're doing this resource interface, right? So it's incredibly powerful to get consistency across a large scale of an API surface area. All right, so let's talk a little bit more about operations. Let's see, where are we? Let's check out step 4 and see where we are on our journey. So this is interesting. So what I've actually done here, and I'm going to move this over a little bit more. So we started with this notion of a common interface, and that's actually where we started in Azure. And what we realized is, hey, we should be thinking about splitting out the actual operations so we can model the operations independently. And so this is what you see here. I've factored out independent operations. So here's the list that we were talking about before. Here's the read that we were talking about before, and the create that we were talking about before. Okay. Now, there's a couple of interesting things here. Notice my list operation has kind of this model right on top of it. Now, you can put this model anywhere, but in the list operation, one of the things that we like to do is say, when you return a list, you should return a JSON object with a collection inside it called value. And that's where the actual list of stuff is. And the reason we do that is because if you ever want to add any information around that list, maybe it's metadata about, where the list came from, or,
pagination, or,
Well, pagination is a separate thing, but like metadata about the contents itself. You can't add anything according to our guidelines. That's a breaking change for us. And so when a team goes a breaking change, there's a whole breaking change policy. You have to support, if it's approved, you have to support that API for 3 years, and you have a new API. So this is a this is an expensive thing to realize down the road, like, oh my gosh, I need to add something, before that array of values. And so our default way of doing that is to say, return an object, have a value inside of it, and that's where your content lives. To your point of pagination, adding a next link saying, oh, I've just realized that I don't have 100 items in my private preview. I now have 100 million items as people are using my service, and I can't return those. We do pagination and say your default should be a next link. And if you don't return it, that's, if you don't ever return it in your service, that's fine. But you're indicating to your downstream clients that this is going to be a pageable list. And again, adding a next link is a breaking change. Okay. So we actually model a list, right? So here's our value, here's our next link, and we say, hey, the list operation returns this list object. And so now we have a lot of confidence that if a team is using our core libraries that has this, pagination and this sort of encapsulating object are going to be there, right? And again, this is really important for breaking changes. Yeah.
Yeah. Also, just another great example of reuse. We have some guidelines about what our sort of payloads should look like when you send back a list of data. And we full disclosure, we're starting to use TypeSpec internally at Zoopla for our own APIs to generate OpenAPI.
That's awesome.
But yeah, before that, we were sort of just had to keep following this best practice every time we created a document. Now I just get to reference this type per se, and boom, it's everywhere. It's great.
Yeah, you want another brown M&M? How about another brown M&M? Application merge patch plus JSON, right? So we say, when you update an object, you should use patch, and that's great. So people use patch, but content type isn't application JSON merge patch, right? And so it's a little detail, and it's easy to miss, and like this is another thing that it's a brown M&M, right? You got to read all and so we're making it easy for you to do this, and the same pattern applies here, right? Here's my body, and I do a merge patch here, right? And so this basically says this is what I'm taking in. And so now we've taken those individual operations and we factored them out and say my common interface, list is now a list, read is now this read, create is now this create, and delete is delete. Okay. And the other thing about the operations is when you define them, you can define your return codes exactly the same way, whether it's the 204 is one that we see with a delete. We always say you got to return a 204 and nothing, right? And teams don't always do that. And so now we get much more consistency here. Okay, great. So now none of these things really have changed, right? I still have my resource interface, but I've factored all of that out into something common, and my API definition has stayed the same. So I'm doing this refactoring just like I would code. The results are the same. So again, this very code-like experience here. So now let's make things even a little more interesting. So now I've just checked out step 5 of our stepwise progression here. So now let's talk about how we start to use those things. Okay, so here's our common interface again. And one of the reasons that we factor them out is, what if not all of your resources do all of those operations in the resource? Well, do you want them defining, now all of their individual operations like we do up here? So this is here's the post operation. So it's a post, it's an operation, here's the post action. And you don't want teams necessarily having to do that. You still want them to use your common operation definitions, but you want to enable them to have the flexibility to say, you know what, I don't do updates. Here's wingdings. You can't update a wingding, right? You can get a collection of them, you can get one of them, and you can delete it. But what you can't do is update them. And so now I provided my team a standard way to do the standard operations selectively. And this is actually one of the design patterns that sort of originated in our Microsoft Graph team, because they're using TypeSpec as well. And so like us, they had this common interface, and they're like, you know what? We want our service teams to explicitly declare the operations they do. But we want those to be consistent when they do it. So now what we're saying is, as a developer, I have to say, I do a get, I do an update, I do a delete, right? And so now I know I'm making an explicit choice there. And that's one of the other things about TypeSpec that's really inherent is you're being much more intentional about your API design, right?
Makes sense. Yeah, I love it. This is awesome. This is really cool.
All right. So now we've got some pretty good stuff here. And, one of your colleagues has come along and said, hey, Josh, this TypeSpec stuff's awesome. I want some of it. And you're like, that's great. You know what I'm going to do is I'm going to build you a library. And so now step 6 introduces an API library. And so here's what I've done. So now up top, I've said I'm going to import the API library, and you can publish these yourself, to npm and pull them in and whatnot. So you can actually, you can publish your own library and say, here's how we do it. Notice here I've got a different namespace as well, right? So I've taken everything out of this demo service namespace, and I said, no, this is in my API library. And so again, a very code-like experience. I'm importing a library, and I'm using the library here.
So let me just make sure I've got this. So what you've been doing here is showing us we had this sort of long format TSP file. You've been factoring it to make better use of reuse almost, with these like composable components. Now you've taken those reusable components, extracted them into a shareable library. So I'm guessing like at Microsoft, you have some big shared library now that everybody uses. So nobody does the, sorry, I've forgotten the name of it, but the sort of the like merge patch would be an example maybe.
Correct.
And the other one that had like next link in it. I can't remember the payload.
And we call that Azure Core, right? So we say when a team starts with TypeSpec, you start with Azure Core, and away you go, right? And so you can think of this as, when you're building libraries, I start with Express, right? Or Flask or whatever it is. It's the same thing. I start with Azure Core because it gives me sort of the guide rails for me to be successful. Okay. So our common library now has our error model in it, has our enumeration in it. We factored out our common operations inside of it. Here's the list that we were talking about, the patch that we were talking about, and our common interface. So now if we go back to our main.tsp file, what we've effectively done is say, okay, I'm just going to import that. And now it becomes much, even more concise. And I'm really focusing on what's in my service, right? In my service, I have models for, widgets and gadgets and things like that. And then here's how I expose those on the wire. But notice that my OpenAPI document, this hasn't changed at all, right? This is the exact same OpenAPI document that we've been sort of iterating on over and over again. And again, it now starts to grow and grow and grow. So we have, I don't know how many, 1,500 lines, 1,200 lines of OpenAPI, and we've got less than 100 lines of TypeSpec, right? So my cognitive load, as I start to understand the libraries and how to use TypeSpec, really is really reduced and focused. All right. Now, one other thing that we did in our library, and I sort of snuck this in to see if you were paying attention here. Oops, that's our OpenAPI.
Promise I was. I just don't think I noticed that.
Yeah. Okay. So we've covered a lot of ground. So one of the things that again, we, every organization that I talk to about stewardship, and a lot of organizations, large and small, are asking, how do you manage all of the Azure API surface area, right? And how do you do it? And we really sort of have these 3 pillars of stewardship, right? It's this notion of education. The next one is this notion of empowerment. And the third one is, the second one is enablement. And the third one's empowerment, right? So education, we try to produce, video, guidelines, material, things that developers can use to really understand more about exposing services properly in the way that Azure would like them exposed. Then we do things like TypeSpec. This is the empowerment. We use spectral linting as well internally. We use auto-rest. We have some linting and auto-rest. We've got a tool chain, built up that does all of this. TypeSpec is a huge part now of this, enablement piece, because we're providing reusable libraries for them. We're providing a real code experience for them to go off and build this. And so this notion of enablement is all around, tool chains, tooling, things like that. The third one is empowerment. At the end of the day, I'm not responsible for that service, right? It's the team that's running it. They understand the cogs. They understand the decisions they have to make, and they understand their business as well. And so we're trying to empower them to make better and more informed decisions about higher order things, right? So this really shouldn't be about using a post or a put or a patch. It should be about, how is your service going to grow over time? Are you avoiding breaking changes? And here's an example I've talked about before with our Maps team. So our Maps team has a number of other service providers that they work with. And they came in and we were talking about one of their APIs that returns GeoJSON. And that's a content type that you're returning. And so the discussion that we had was, are you sure you want to return GeoJSON, or do you want to wrap that and return the GeoJSON in something? Because if you return the GeoJSON directly, that's your API contract. That can never change. So if you want to ever involve that, give information about that GeoJSON, where it came from, what it is, any other information, like, you can't do that. And so that's the kind of discussion that, as an API steward, as somebody who understands and has seen lots and lots of APIs, that's the kind of conversation you want to have with a team. Not like, hey, you got to change your return value, your return code from a post or a patch or a delete or whatever, right? That's the mechanics, right? We should be able to handle that. And TypeSpec is a way for us to handle a lot of the mechanics so we can have more intelligent conversations with our teams.
That's awesome. Yeah, really interesting. And actually, in a few ways, I'd like to pull on this thread a little more. So, I mean, you introduced this concept you called API stewardship, and the three pillars of it. What I've seen in the past, and even actually when I was at Microsoft many moons ago now, we had what I used to call like the Jedi Council. A little bit disparaging. I would use it. We had this at Stripe as well when I was at Stripe, and what that was a form of governance where if you wanted to ship a new API, you had to send your proposal to the Jedi Council. They would probably give like a lot of feedback on it traditionally, and would sort of control and bottleneck, frankly, the whole process of you getting something out.
Yeah,
and the goals of this are very good. They're trying to drive consistency, better API design. I mean, Stripe especially is, still somewhat held in sort of the public field as like the gold standard, honestly, of like what a great API looks like and what a great developer experience looks like. I'm sure Azure is there too. But the reality on the inside was I personally found it a tremendous bottleneck to us getting stuff done. That team was very busy, had limited resources, sometimes had limited context and limited time to engage in the context of like why we'd made certain decisions. So, they were able to only spend a slice of their time on things. And it definitely slowed things down. Now you could argue that's good or bad, but we definitely went slower than we might have done. Stewardship sounds different. Like, is it a different take on this? Is it like the replacement for that process?
Yeah, I think it is. And we had, in fact, prior to me joining Microsoft, we had the gates, right? And I've talked before about this notion of, hey, what you really feel like you need is you need a gate, right? You want to put a gate in the man, I just want to watch everything that goes through there, right? And like you want a gate. On the other side, like your service teams have pressure to move fast. They're like, just get out of my way. Like I want an Autobahn, right? And I'm going to go, 120 miles on that Autobahn because I'm competing in the market. So, get out of my way. And so I talk about this notion of a roundabout, right? Imagine you're coming along, you're driving fast, and you have a roundabout, and you have to slow down and sort of take a look and kind of, okay, and now I'm going fast again. And that's what I think is a good analogy for stewardship. And of course, you want to do this as early in the process as possible, because I would be shocked if you said every team came to you, when you were at Stripe or at Microsoft and said, oh, I'm going to be releasing in 7 months. What's my API look like? I'm releasing in 7 days. Just give me the checkbox, right? And so we try to engage early, and we try to say, here are the kinds of things you need to look at. Here are the kinds of things you're going to be concerned with, right? One of them is order by, right? If we see an order by, like that's a technology decision as much as it's an API decision. And like, do you really need to do that? Because if you switch your underlying database, your COGS are going to go way up. Did you know that?
Oh, by the way, for listeners, COGS, I used to think COGS meant like the internals, like the gears of a machine.
Yeah, right.
It means cost of goods sold, right? It's how much it costs to operate the service.
Right.
Yeah, I only learned that at Microsoft.
Yeah. And so anyway, so as we think about stewardship, it's not that we don't need to have rigorous things in place. So breaking changes is a gate. That's a hard gate. Like if you introduce something in your API or your SDK that's going to break, that's a hard stop. But what we want to do is give you the tools, give you the information, and empower you to make informed decisions, to slow down on the roundabout, look at your API, think about the developer experience, make any changes that you need to make, and then go. And it's another reason why we strongly encourage a preview of your APIs. So our policy at Microsoft is you can preview your API. If you change it, you only need to support the old one for 90 days, right? So we encourage previews to say, do you really understand how developers are going to use this? And if a team comes in and says, oh, yeah, I got the portal blade right here, and they're going to go in and they're like, well, how is somebody going to use this in their pipeline? Oh, that's interesting. And so we challenge them to think about different use cases and different ways their API is going to be used, and then actually try to find a customer in their preview that's going to exercise the API from curl or in their pipeline or some other mechanism that they didn't think about, and iterate that way. And so we try to do that as early on in the possible, and that's sort of that roundabout analogy that we talked about.
Yeah, I think this is really interesting, actually. I mean, we're coming up to an hour, so we probably have to wrap it soonish. But I wonder, actually, it might be good getting a panel of folks like yourself and a couple of other people together to talk about councils, stewardship, and governance. It's an area I'm passionate about, and the team here at Zuplo is passionate about, and we're looking to try and automate as much of this as possible. To sort of go to a world of governance with a lowercase g, so it's less of a bottleneck. And certainly some of the advances in AI and LLMs right now make it look like even more is achievable in terms of that automation potentially now. So it's super exciting. So we should follow up on that. I do have a couple of questions for us to sort of wrap with, though. Like one slightly spicy one, Mark. No, I didn't forewarn you of this. Is when I look at TypeScript now, this is awesome. This is great. Why do I need OpenAPI anymore? We're using it as a tool to generate OpenAPI. Do you imagine a world where we just forget the generation and we just use TypeSpec?
No, I don't. It goes back to this notion of a contract. It's interesting. That's not a spicy question. I've eaten Thai food before, so I've had this question before, right? It's why folks like myself, like Daryl Miller, Mike Kistler, it's why we participate in the technical steering committee for OpenAPI. This OpenAPI is the contract, right? And I can't give you a TypeSpec collection of TypeSpec files and say here's our contract, right? Because you have to compile that. You have to run those through the emitters. You have to understand what the decorators do. So I look at TypeSpec as what's a great authoring experience in a code-like way that gives me easy reuse, that allows me to codify my guidelines, the nuances of the way I do REST interfaces or whatever interfaces, but in our case, REST interfaces, right? It's codifying my guidelines. And our guidelines, if you read the Azure REST guidelines, like we can't lint all of those things. It's not like, oh, I can just go lint these things. You can't do that. We get a lot closer when we have a language. But what I'm producing is a contract. I'm saying, this is my contract. You can feed that into your tool chain. You can throw that into, your APIM. You can do that's the contract. And so I don't foresee a world where these things don't exist. What I see is, here's a way to do API first in a code-like way that gives me a great authoring experience that can now feed my tool chain in a much more consistent way, in a way that I have a higher degree of confidence, adheres to my guidelines, that is easier to change and manage over time. So that's where I see these two things really complementing each other, not replacing each other. And I love Thai food, by the way.
Yeah, there is some comment here about Americans not really eating hot food. There is some joke here. I remember when I had, actually in the Microsoft Cafe, when I first moved over to the US, and I went to the Microsoft Cafe, and they served a Vindaloo curry, which is a curry that's very popular in England, but it's spicy as hell. I mean, hell is the right term here. In England, it is anyway. And here it's very mild. I don't know. It's not even, I'm sure some Indians are listening to this and laughing at me as a British person eating curry. But anyway, everything's relative.
Yes,
but yeah,
no. I think I've dined with Indian folks who've given me authentic Vindaloo.
It's a different world. It's a different world.
Be very spicy, yes.
Yeah. Anyway, back to the OpenAPI stuff. That actually makes a lot of sense to me. And in the same world where, I don't think anyone sees a world where you run TypeScript natively today. It's going to be transpiled to JavaScript. JavaScript is the language of the web, and or one of them. And it's going to stay that way. So yeah, that actually makes a lot of sense to me. Mark, this has been great. I've learned a lot, genuinely. Obviously, we do some prep for these calls, and I'm feigning ignorance to some degree, so I can sort of help people who are unfamiliar with the subject understand what we're covering. But no, I actually learned quite a bit today about TypeSpec. So we covered we got into some depth there that was awesome. So thank you so much for taking the time to chat with us.
Absolutely. I'll leave you with two things. For folks that were following along, there is a magical step 7 in there that will add a linter in here, which will enforce your API versioning rules. So that's a little bit of homework for folks. You talked about getting a group of folks together as well to talk about stewardship. I'll give you a link to a repository. I started taking some of the talking points that I have about stewardship and trying to capture them in a pattern-like way inside of this API patterns repository. And so it's really what I've been calling this API practice patterns, if you will. What are the things as API stewards you should be thinking about, you should be doing, because the hard gates and the governance, they don't scale, right? And you really need to, as your teams need to move fast, as your organization grows, you need to think about putting in processes that scale. And I think stewardship is a way that you can scale and get the governance you want when you complement it with the right sets of tools and the right sets of education. And so I've started, putting together in sort of pattern form some of the talking points that we have. It's in GitHub. It's not very built out yet because, day job and all that, but there you go.
That's awesome. I'll include that in the show notes. But I'm quite motivated for us to pull together some folks to have a discussion about this in more depth, where that's the focus of the conversation. Mark, I want to say thanks. Thanks for taking the time. It was really interesting, and look forward to speaking to you again. Thanks for all the great work, and for I think Microsoft's just done some great open source stuff, huh? Like putting this out open source. We use it. We're not very affiliated with Microsoft anymore. But yeah, we use so much stuff you folks put out, GitHub, VS Code, TypeScript. It's great stuff. Keep it up. Thanks.
Thank you.
Thanks, Mark.
Thank you for having me.
Yeah, no problem.